Hello guys, today we're going to talk about a couple of topics in this class. One of them being the discount rate or the interest rate or the cost of capital. So actually all those three have the same meaning. It's basically interest rate. Interest rate or discount rate or the cost of capital, all those mean the same thing. That's going to be one topic for today. And another topic for today is going to be time periods. So we're going to talk about discount rate and time periods as part of our discussion of time value of money. This class and the class from last week is all about time value of money. And as I've mentioned last week, the four main topics, the four main things to calculate within this time value of money are the present value and future value. We already discussed them in the previous class last week. And the rate, the discount rate, and the time period, the how long is the investment for. Those four parts to calculate, those four topics to discuss are all within time value of money. So today we're going to have a look at the second part of all of this discussion. We're going to start with rates. As I've already said, discount rate, interest rate, or cost of capital is all the same thing. And last week you saw this formula for future value, where future value, the amount that the investment will grow into, is equal to the original value, let's call it present value. Presently, today, you make an investment, and over the years, over the amount of time t, that investment is going to grow at this rate of some percentage per year. How much will you have in future? You've learned all of this in the previous class, but using this same formula, we can actually derive the formula for the interest rate or the discount rate or the cost of capital, which is the ratio of future value to present value, all into the power of 1 over the number of periods, t, minus 1. Okay? So that's a formula you maybe want to take a note of, but as you know, as we did last week, a lot of our calculations are actually going to be done in Excel, and there's a different, simpler formula in Excel. You'll have a look at that in this example. So let's have a look at this example. Let's say we're looking at an investment that will pay you $1,200 5 years from now. But to get this $1,200 5 years from now, today you need to invest $1,000. So today you're investing $1,000, 5 years later you'll have $1,200, right? How much is your interest rate? Well, is it 20% more? Is the interest rate 20%? Well, not really, because another thing to learn about interest rates is by convention, meaning that let's just agree that if we don't mention any particular details about the interest rate, it's going to be an annual interest rate. It's going to be annual compound interest rate. We also mentioned that in the previous class last week. So if it's an annual compound interest rate, then the actual annual per year, the interest rate that you're earning per year is not 20%. You're going to earn 20% in 5 years. And it's compound, that includes interest on interest. That means that annual interest per year is going to be less than 4%, right? It's not simply dividing 20% by 5. That would be the case if it was a simple interest rate without interest on interest, right? But if the problem doesn't tell us, okay, calculate the simple interest rate per year, then the calculation is a little bit more tricky as opposed to just dividing extra 20% by 5. Okay, so one way to do that is, of course, to use this formula that I've already showed you. The rate in this case is going to be the ratio of future value, $1,200 5 years from now, over the present value, $1,000, into the power of 1 over the number of periods. In this case, we have 5-year annual periods, minus 1. All of that is going to give us 3.7%, right? But I would suggest that you maybe learn another formula to calculate exactly the same thing and use that formula in Excel, which is simply hit equals in Excel, type rate, open the brackets, and you'll get all the hints. So let's jump into Excel to have a look at this particular example. So here we are in Excel. Our present value is 1,000. Our future value is 1,200. Our time periods, I mentioned that NPER is the number of periods in this Excel formula. I mentioned it in the last week's class. Our number of periods is 5, and what we have to calculate is the actual rate. For any problem that you have on your exams, it's a good idea to write this down first to make sure you understand the question, to make sure you understand what you have to calculate. Because all of the calculations are done by the computer. The things are pretty easy for you. The main thing for you is to understand the question and to know how to solve it. But the actual calculations, the actual formulas, as you see, are pretty easy. You don't really even have to use formulas like these. Instead, I'm going to use a shortcut in Excel. I know that I have to calculate the rate, so just hit equals and type rate. Once I open the brackets, I'm going to get the hints over here. NPER is the first thing I have to enter, so I'm just going to click here. Then comma. The next hint is highlighted, PMT. We haven't talked about PMTs. Next week, we're going to introduce this new variable, PMT. For now, I'm just going to skip it. Another comma. PV is highlighted. Presently, I'm going to invest $1,000 out of my pocket. We talked about the direction of the flow of money and the sign, but let's just put it positive for now. Let's see what happens. Another comma, FV, and just ignore the rest. Close the brackets and hit enter. We see there is a bit of a problem over here, and it's not because there is not enough space to give us a number in the cell. The problem is because these two, present value and future value, they should have opposite direction, because you originally invest out of your pocket. Remember from last week, that's a negative value, and 5 years later you get the money back. That's a positive number. So if I change this to a negative 1,000, boom, we got an answer here, and that's rounded. You can use this button in Excel to have a look at more details. That's the same as you have the answer on your slides in Moodle. Okay, so all of these materials are already on Moodle. So the thing I really want to highlight for today is this formula in Excel. This is that formula. You just hit enter in Excel, type rate, open the brackets, and you'll get the hints. Just follow the hints. Here is what you're gonna need basically. First, enter the number of periods, comma, then you'll need the PMT. Just skip it for now. Starting from next week with more difficult problems, you will not skip it. We'll add more details for the PMT. So 2 commas to skip the PMT, then the present value. Remember, this probably is negative. Future value is probably positive. Close the brackets, hit enter, and that'll give you the answer. So coming back to our lecture slides, actually, most of the class today is going to be going over many examples for these two topics. One being the interest rate, another being the number of periods. Okay, so let's have a look at another example for the interest rates. Zoom in too much. Now suppose you have an investment that will double your money in 6 years. So 6 years, double the money. Okay, and today you invest 10,000, right? So if you double the money in 6 years, what's the actual rate? What's the actual interest rate that you're earning? Yeah. Of course, double the money is 100% more, but that's 100% more in 6 years, not annually, not per year. And if we don't specify anything about the interest rate, we have a convention that it's going to be an annual compound interest rate. Okay, So the answer is not simply 100% because I'm doubling the money. Okay, the answer will have to be calculated using that formula in Excel. Okay, or you can still use this formula to calculate this interest rate by hand. Okay, so let's see what we have. Let's jump back into Excel. So I'm gonna use this same space over here, change the numbers. I already have the formula. That's gonna give me the answer, right? So my original investment is minus 10,000, yes, and I'm gonna invest it for 6 years. But the question is, how much is my future value? Well, again, if we look at the problem, here's an example of where the most important thing for you to do on the exam is to understand the problem correctly. Read it 2-3 times before you start answering it. So where's the future value here? I don't see any other numbers. Well, if I double the money in 6 years, then I will have 20,000 after 6 years. That's double the 10,000. So 20,000 for the future value. Hit enter, and I'm earning 12.246%. Right, 12.25. Yeah, if we round to only 2 decimal places after the point, it's going to be 12.25%. Yes, or in decimal numbers, 0.1225. Okay. Again, as I said, today's class is mostly examples for these two topics. Here's another example. Suppose you got a child, only 1-year-old child for now, but later on you will need a lot of money for the child's education. You will need $75,000 17 years later for the child's education. Okay, right now you only have $5,000. So you plan to invest this $5,000 for 17 years to make sure you have enough money for the education of that child 17 years later, right? So this money has to grow up into that $75,000. What is the interest rate at which this money has to grow so that you do have enough money after 17 years? If this money grows too slowly, you will not have enough. This will not grow up to 75. If the 5,000 investment grows too slowly, perhaps in 17 years, it will only turn to 25,000, right? So it should grow at least at some rate or faster. So what is that rate? Let's calculate that. Let's jump back into Excel. Again, the formula is actually the same. So I'm just going to change the numbers here, and you'll see the calculation is very easily done by Excel, done by the computer. So presently, today, you're going to invest $5,000, and in the future, you will need $75,000, and that future is coming after 17 years, right? Okay, bit of a mistake here. That's $5,000, not 500, and we get something like 17.27%. 17.27%. And that does agree with what we see on the slides. Again, all these slides are on Moodle. So when you have chance, you must review before your exam. Okay. Let's have a quick recap with additional questions. Okay. Suppose you choose one of the following investments. Okay. Either you invest $500 today and receive $600 5 years later, okay, or you invest $500 and receive 4%. Which is better? Well, to answer this question, let me calculate the interest rate for the first case scenario and compare if it's better than 4% or not. Okay, we already know how to calculate the interest rate. So if I invest $500 now, I will receive $600 in future, and that future is 5 years later, so the number of periods is 5. That means that I'm earning 3.71% per year it's not as good as the second option where I'm earning 4% per year. Okay, so if you have to choose one of these two investments, you should better choose number 2. Now you know how to answer these sort of questions. Again, make sure you prepare for your exams in the future. And next, let's move on to a number of periods. Again, remember, in this whole chapter of time value of money, we look at 4 main variables: future value, present value, rate or interest rate. We already covered all 3 of those variables. And lastly, number of periods, the time that the investment takes to grow from present value into the future value. Again, this time t can be derived from the formula for this future value. This formula for the future value is really convenient in the way that it's clearly understandable, right? In future, your present investment is going to grow at the interest rate over the period of time. We looked at how this formula is actually created last week. So again, if you are not sure of how exactly this was created, have a look at last week's material. Everything is back on Moodle. So from that you can derive what's t, and of course you're going to use logarithms for that. For example, a natural log over here. T, the time that it will take for the investment, an original investment, the present value, to grow into the future value at a given rate, is the ratio of the natural log of the ratio of future value over present value to the natural log of 1 plus the interest rate. Okay, so of course with a scientific calculator you can calculate the values of logarithms, the values of ln, and you can do that by hand with a scientific calculator. But again, you have a bit of a shortcut if you use Excel, okay? And that shortcut is simply hit enter and type NPER for number of periods. Yes? Enter, open the brackets, you'll get all the hints. Enter the numbers that the computer asks for, and you'll get your answer. Let's try that in Excel. Again, it's a good idea when you get any question to first write down what do you have. Let's say you have future value, present value, you have the rate, and this time we want to calculate how long does it take. So NPER is the unknown that you have to calculate. Okay, let's jump back in here to get some examples. So our first example is going to be the investment of 15,000 over here, and that's an investment that you hope will grow into 20,000 after some time, so that you can buy a car later on. And this 15,000 is expected to grow at, let's say, 10% per year. How long will it take you for the 15,000 to grow into 20,000? Right? So the main difficulty with any of your questions on the exam is to understand what is the question about. What do I have to do with this question? What do I have to calculate? Any kind of questions that will ask you how long, that of course is to calculate the amount of time. That's when you have to use this formula. Equals NPER, open the brackets, everything else will be given to you. Okay, you'll get the hints of what you need to enter. Let's try that. So future value is, of course, 20,000. That's how much I will need for the car. Presently, I can invest 15,000 with a negative value as that's going to go out of my pocket into the investment. And let's say I'm investing at an interest rate of 10%. 0.1 is 10%, or I can actually use the percentage sign as 10 and then percent. Either way is fine. The computer can understand both. Okay, let me scroll down a little, and we're going to use this formula. As I said, NPER is going to be, let's say, in this cell lower, equals NPER, open the brackets, and I get all the hints. First hint over here is rate. Give us the rate. You could click here, comma, next PMT, As I mentioned, we're going to talk about PMT in the next video. So we're going to skip it, another comma. PV, click here, another comma. Future value, FV, click here. Ignore the rest, close the brackets, enter, and you get 3. That's 3 years and a little bit for you to wait for this investment to grow into 20,000. Let's try this formula again so that instead of 0.1, we show that we can also use 10% as an input into the formula as well. So equals NPER, open the brackets. For rate, let's now click on 10%, comma, comma, to skip the PMT. Next is PV, negative 15,000, another comma, 20,000, close the brackets, enter. You see, the answers are the same. Although in the first case we entered 0.1 for 10%, in the second case we entered 10% for 10%. The computer would understand both, and it shows that we have to wait for slightly more than 3 years for this investment to grow into 20,000. Okay, so again, that's perhaps the second most important formula for you to remember, to highlight. So let's highlight this formula. What you're going to do is simply hit enter, type NPER, which stands for number of periods. Open the brackets, you're going to get the hints. The hints are going to be basically first enter the rate, then 2 commas to skip the PMT. We're going to talk about PMT in future. Then enter present value, enter future value, ignore the rest, close the brackets, and hit enter to get the answer. We can have the same solution with the formula involving the natural logarithms, but again, as I've mentioned, perhaps Excel is going to be a little bit quicker for you. Next, let's just have a look at more examples. Coming back to the slides, let's say again, we are comparing the amount of money that you have now with, let's say, the amount of money you will need to buy this furniture. And let's say your investment of $500 today is going to grow at an interest rate of 6%. How long is going to take? So again, how long? These kind of questions usually imply that you have to calculate NPER. How long is it going to take for your $500 to grow into $600 so you can buy that furniture? Okay, let's jump back into Excel, change these numbers. I already have the formulas pointing to those numbers, so I think I'm going to get the answer very easily if I change these numbers. So I'm going to need $600 later. Right now I only have $500 to invest, a negative sign over here, and that's growing at only 6%. That's 0.06 or 6 and then percent. Hit enter and I get the answers of, again, slightly over 3 years, 3.13 years. Do I have an answer here? Yes, we do have more of the answers at the bottom of these slides. Again, go back to Moodle to review everything. And that basically concludes this whole chapter on time value of money. To review a little, we covered 4 variables: how to calculate present value, how to calculate future value, how to calculate the rates, discount rates, interest rates, and how to calculate the time that the investment will take to grow into that future value. In Excel, that is denoted with NPER. Have a nice day and good luck on your tests.